Guys, welcome back to the channel. On the last episode, when you guys tuned in, we built this sway bar setup for the rear suspension. This week, we are going to install some coilover rackets on the back of the suspension back here to get this all finished up. And then we're probably gonna move into the front suspension. We have some parts coming in this week, all our spindle, hub setup, and we'll go over what we're gonna do for the brake setup. Since the last time you guys met on here, I have worked on the truck itself a little bit. So I got the truck up on jack stands and started disassembling some things. So we got the radiator out, E-fans out, headers were out. We're gonna start slowly picking pieces off of this. Probably do that off camera because it's not super interesting. You guys all seen small blocks and what goes into them. So we're gonna start getting this motor ready to get pulled out. And we also got a new air compressor. So the Ingersoll Rand failed again after the last episode, so I wasn't able to do any plasma cutting. This one is installed and ready to go, so we should be okay to run for the next, I don't know, 30 minutes until it blows up again. I'm super impressed with them. So let's get started on the cutting. Okay, so we got these all cut out. Sort of cut like crap. I had to knock off a lot of dross with the pliers first and sort of have them with flap test, but they cleaned up all right. So what we got going on here is we have inner brackets. These inner brackets weld to the frame, like so. And these are spaced apart about 1.5 inches. And then what happens is, I'll just take one set here. These outer brackets are bolted onto the inner brackets. So these have some adjustment. The reason we didn't make it all just one bracket with a bunch of holes is because your coilover, your eye on your coilover for the Heim needs to have clearance for the coilover body. So you sort of need a way to manipulate it up and down without interfering with that. So we went with a two-piece design like this. So these are going to weld on in pairs onto the chassis. With the center line out about 1.5 inches from this plane, so they'll be mounted up here. So obviously with space between them, and then the brackets will be bolted on to those. So what we're going to do next is we're going to get these cleaned up. They're already cleaned up a little bit, but I need to knock the slag off the ones that we're going to weld. We're going to transfer our markings onto the chassis like you've seen me do before, and we are going to weld them up. I also need to clean the chassis up because everything in Pennsylvania is very wet right now, and I had to wipe the entire chassis down with WD-40, which I do not like doing because I'm still welding on it, so it makes everything a nightmare. So we will wipe individual sections down with acetone and get it all cleaned up. Okay, so next up what we got is I got some aluminum tube. This is just 60, 61, T6 extruded tubing, and I got the brackets. So what we need to do is cut out some 1.5 inch spacers, 4 1.5 inch spacers, and those are gonna keep this bracket assembly that we're welding to the truck from collapsing when we bolt these on, so we don't bend them inwards. So I'm gonna get started on that, and then we'll get these ground up and start measuring the truck out to get everything welded on. Yep, so we got the 4 spacers cut out. Everything looks good here. They actually came out really tight and close to each other. I think the farthest one off was like 0.010 of an inch, but pretty good for a saw. Dad was able to get those cut out pretty accurate. What we got going on here is I have them bolted together in the farthest position, and this will keep our spacing when we're welding and keep everything nice and parallel. So we'll go ahead, and the next thing we're gonna do is we're gonna go over here to the truck, get some plate, and start measuring out our dimensions for where this needs to go on the chassis. Okay, so you saw us, we got the rear drop, we welded these tabs on, and I got the hardware in there. Everything looks pretty good. So there's a little bit more slack in this interface from this outer plate to the inner plate than I like. So you have to sort of pull it in the direction that you want to tighten it up. You can probably get about an 1/8 inch of wiggle up here at the front. So whenever we tighten those up, I'll have to make sure that maybe just put the weight of the truck or the weight of the coilover on it, and then just sort of snug up this hardware so everything's set at the same point. But overall, pretty happy with that. So what we're gonna do next is we're gonna get the hardware that came from Speedway over here out, and I got some different bolts and brackets, and then we also got the spindles in, and we'll get those mounted up. Okay, so I got some Speedway, I threw the boxes out. They're Speedway coilover studs. So this is a 4.5 inch, 4.5 inch, and a 4.5 inch over here. They are made for coilover studs, which obviously we're going to use them for to tie this to this when we get our coilovers in. But I'm also using it as a panhard bar mount. So the panhard bar mount is just about right. Unfortunately, I don't have quite enough thread poking through the backside to get into the nylon lock nut washer or lock nut. So I'm going to take this over to a buddy's, and we'll chuck this up and probably take off about 1/4 inch to be safe. We got plenty of clearance from the back of the punk in there to the panhard bar. So we'll just sort of shave that back to get a little bit more thread engagement there, get that all centered up. One thing I did notice is when I welded this bracket on to the rear, I overbent on the press brake. This angle was slightly inward, and I took it and I put it in a vise and just sort of tweaked it back. When I did that, I'll show you from a vertical view here. You can see it sort of put like a little double angle in it, like in a little S shape, and that S shape sort of coincides with where the stud mounts. So the stud is sort of kicked outwards in the back. Now it might be like 3 degrees or 2 degrees out, but it's just enough that you can notice it with the eye. So I'm gonna have to figure out what I wanna do there, if I wanna try to bend that piece back or how I wanna go about that. But that's the one thing that I saw that I'm gonna have to sort of fix and tweak and get that more aligned. But overall, pretty happy with the way it looks. They're definitely nice for the money. I think they're like 12 bucks a piece or something like that. And they look pretty sturdy, and they fit nicely with our mount here. So pretty happy. Now the next thing we're gonna do, we're gonna throw the front spindles on and see how they look. Okay guys, so there you go. I got the front suspension on the truck. Spindles are in. Everything articulates very nicely. No binding or anything like that. I went ahead and checked like the caster on the truck, placed in here. I'm gonna make sure we get this straight. We got a good 8 degrees, which was what I was shooting for. If you even look, I think my notes are for 8 degrees caster from before on our measurements. And same thing with this wheel over here. Pretty close, it's upside down. So that's 7.5 degrees of caster. So obviously not shimmed, nothing's moved around, but just line to line with the measurements, welding everything up, we're within 1/2 degree. Same thing if you look at the camber. Let's go ahead and turn this on, turn that off. If we just look at the camber, we got about a degree of camber right now. And nothing here. Let's go approximately a degree, 1.3 degrees, 1.25 degrees of camber. So even still, this thing's very close. So I'm pretty happy with that. Another check that we were gonna do is, if you look, I'll go ahead and zero out the camber now. The camber gain, let me zero this out. Camber gain, so this center line point here is about 60% of the wheel travel, or from the track width. So 60% of the pivot point to the track width is right there. And if I increase that approximately, let me just lift this up here, 2 inches, I'm getting about 4 inches of wheel travel, about 3.5 inches. And you'll see that reflects here into a 4-degree camber gain. So that's pretty good. That would be about a 5-degree body roll, and we're getting 4 degrees of camber gain. We're gonna set it up with about a 1-degree static camber. So that's about perfect. That's about where I want it. 80 degrees or 80% of your camber gain, your body roll to camber gain is pretty good. So I'm happy with that. Anything else, we would have to get pretty dramatic with the geometries, which induces other issues. So yeah, that's the front suspension. It's looking good. Gonna try to keep moving forward here. We have some more parts coming in, so later in this video you're gonna see the hubs going on, and we'll hopefully get rear hubs going in here also before the end of the vid. But for now, that's it for me. Okay, so it's 5 days later. Parts started to coming in here for the hub assemblies and everything like that in the rear and the front, but not everything is here yet. So what we're gonna do today is we're gonna install our, this is for the rear sway bar kit. I'm using a torsion bar back there, so we're gonna put a torsion bar stop kit in, and then also install these bump steer kits, which I'll show you guys how those all go in. Okay, so this is a Moose, actually a torsion bar stop kit, and we're gonna put that through here. It's basically just a fancy piece of all thread with nice end caps. So that's gonna retain our torsion bar, or our sway bar setup in this chassis. So anytime you're running these pinch bolts and they don't have the groove, or the pinch bolt intersects the bar, it's not really fully mechanically retained. It's only being held on there by the tension. So you always want to have a mechanical positive retention, which this is going to provide. So we'll get that installed now. Boom, it's in. I'm basically a mechanical mastermind. Pretty much the hardest part of this entire build just got completed. Moving on, put the bump stops on. Or not bump stops, bump steer kit. Okay, so this is a bump steer stud, and what it does is it mounts into any spindle arm. This is made for a Pinto or Mustang 2 style spindle arm, which is what the steering arm is here. It's got that taper, and then instead of your tie rod end coming in here and having the joint built in, it has a stud that you can adjust the position of this Heim joint here. And we have a nut here and a nut here, and then some misalignment spacers added. And what this does is it allows you to, when this is installed, move that joint up and down in relationship to the steering arm. The important thing when you're designing your own front suspension or changing any front suspension components is you need to be cognizant of the steering geometry and its relationship to the lower control arm. There's a relationship between this point and this point that creates a parallel, or a line here, and there's a relationship between this point and this point. Basically what happens is the pivot point at a given length from here to here, where those lines intersect and where the steering rod matches, needs to be equal distant and parallel to this point. So what we're going to do is adjust this joint until those conditions are met. Now, one thing you'll notice is that this is offset. It can be offset. It doesn't have to be in the same plane. Your steering joint here, where the steering rack articulates, doesn't have to be in the same plane. In fact, it can't be, because when you steer, it's not. But it does need to be the same distance as what it would be in the vertical plane between these two datums. So it'd be better if I showed it on a drawing, but if you want to research it, look it up. So we'll get this put in here and I'll show a little bit clearer. Okay, so I got that tightened down. This is very much guesstimated at this point where it needs to be, but you can see I have good articulation in all sorts of different directions, and everything should line up great. We'll have to make some custom tie rod ends. This is some sort of weird right-hand fine thread. This is a 5/8 inch fine thread left hand, so we'll make some adjustable tie rod links with some threaded stock and some taps, but that will be at a later time. We're just trying to get all this figured out because in the next episode we're going to try to make a sway bar setup that needs to clear it. So just need to have something in place. So I'm going to go ahead off camera, install the next one, and then we'll move on to the next thing. Okay guys, we're back. So what I got one of the kits in. The other one's on back order, which is fine, but I can show you this one going on. So this is a Grand National style floating hub. You'll notice right now it's got 5/8 inch lug nuts, lug bolts, studs in it right now. Those are going to come out. I'm going to go over to 1/2 inch so I can run Corvette wheels style with this truck. So I'm going to go ahead and partially assemble this and get it mounted on the truck, show you guys what's going on. But I'm not going to put any of the seals in or anything like that because I don't plan on packing the bearings with grease yet. And since I'm not packing the bearings with grease, I don't want to put the seals in and have to drive them back out and do all that fun stuff. So let's go ahead and get this assembled or partially assembled, and we'll get on the truck. Okay, so like I said, I didn't put any of the seals in. I was just sort of mocking them up to see how they look. This is the floating axle. So obviously this, you can have an axle break, your wheel's not gonna come off. It's retained by this big captured nut in here. This is what actually provides your drive. This is a drive plate, and it slides over here, obviously with the seals in and all that fun stuff, and mounts onto the locking lugs. So the axle then will slide through here and go into the diff, and then this is what drives your hubs. So pretty straightforward. Okay, so there you go. So the cover plate, the axle cover plate goes on, and if you break an axle, just unscrew these bolts, stick something in there. Usually sometimes the axles are threaded, or you can push it through the other side and push the axle out, swap another one in, put the cover plate back on, you're ready to rock. The other thing, the main reason we want to go with floater hubs too is when you don't run a floater hub, your axle can flex and your brake rotor will come up and touch the pads in heavy quartering, and that can cause issues called bump back or pad bump back, and that will cause sort of a spongy brake pedal. So this is just a little bit superior setup for what I'm doing, and yeah, starting to look like a truck's coming together. The back ordered one should be in next week. We're not gonna worry about showing you guys that one because it's the exact same as this. And next up, we're gonna throw the front spindles on. Okay guys, so more parts came in, and what we have here are GM adapter hubs. These are from bigbreakupgrade.com, and they're sort of unique. So what these are is they're actually a 70s to 80s GM Camaro brake rotor that is turned down and then trimmed up and modified so that it can work with Mustang 2 style spindles. The Wilwood ProSpindle that we installed, this is a Mustang 2 style snout on this this spindle here. So if you know anything about Mustang 2, you're kind of limited on the braking options that you have with the factory hubs. And that limitation doesn't exist with these spindles. They have extra mounting provision or beefier mounting provisions for upgraded brakes. So what these hubs allow us to do is they allow us to use GM brake rotors off of the Corvette and the CTSVs, the ATSVs, the ZL1 Camaros, all that good stuff. So all of those brake rotors will now fit these hubs. So how this works is this is like I said, a Camaro brake rotor, and the inner race is removed and it is converted over to a special race, and they include the bearings with that. And then the outer race is a Camaro bearing, basically a Camaro outer bearing, but that is also the same size as the snout that is on the Pinto or Mustang 2 style spindle. So we'll get these installed and we'll go over a couple more of the details about them. Okay, so I got this on here. It's pretty simple, inner bearing, outer bearing. I didn't put the seals on it because, like I said, with the floater hub in the back, I don't want to pound them in. I don't want to grease everything yet. We're just mocking everything up for right now. Try to keep the trash out of it, try to keep the dust out of it, but we'll give everything a good acetone bath before we assemble it. So one thing that you need to note here, these are special spindle lock nuts. So what they do is they take I'm guessing an existing lock nut from some sort of car or whatever, maybe the GM nut, and they turn it down so that it'll fit under the cap. So that's just something you need to know if you're going to get conversion hubs like this, that you need to get the nut or have access to a lathe and turn it down yourself. We also got upgraded ARP hardware. That's always good to go. And for now, we're gonna leave the braking system go. We had enough other stuff, front sway bar setup to finish, all sorts of other stuff to do, that we're not gonna do drop a whole lot of money right now on brake setup. But I did wanna get these because they're important for getting the truck on wheels. We will be going with a GM style brake rotor, obviously new stuff, probably a used set of calipers off of a CTSV is the plan right now, like a Gen 2 CTSV. So that should provide ample braking for the truck, big 6-piston calipers. So for now, I think we're gonna leave it off on the episode. Got these ready to go, got the back ones, the back hub, the other ones coming in for the back order. Got the coilover mounted, or coilover mounted. Next episode, we're gonna be working on that. That is the engine, and you'll notice that we are fabricating things on it. So I'll leave that for the next week so you guys can check out what's going on. But until next time, like and subscribe. Thanks for all your help, and I'll catch you all later.